Have you ever wondered what types of solar cells are out there and why are they important? Well, you're about to find out. Solar cells, also known as photovoltaic cells, convert sunlight directly into electricity. They are the heart of solar panels, capturing the sun's energy and transforming it into a form we can use to power our homes, businesses, and even our cars. In the grand scheme of things, solar cells are a pivotal player in our transition to renewable energy. They help us reduce our carbon footprint, combat climate change, and move towards a more sustainable future. But did you know that there are different types of solar cells, each with its own unique properties and applications? First off, we have monocrystalline and polycrystalline solar cells. These are the most common types of solar cells you'll see on rooftops and in solar farms. They're made from silicon, an abundant and non-toxic element. Monocrystalline cells are made from a single crystal of silicon, while polycrystalline cells are composed of many silicon shards melted together. Then, there are thin-film solar cells, which are, as their name suggests, thinner and lighter than their silicon counterparts. They can be made from a variety of materials, including cadmium telluride and amorphous silicon. Next up are organic solar cells. Although they're not commercially available yet, they offer a lot of promise due to their flexibility, durability, and potential for transparency. Imagine a world where windows could also generate electricity. Finally, we have Perovskite solar cells. These are made from a material with a similar crystal structure to the compound calcium titanium oxide. They're not widely available just yet, but their low production costs and high potential efficiencies make them a fascinating area for future research and development. So, there you have it, a quick overview of the different types of solar cells that are helping us harness the power of the sun. Now let's dive into the fascinating world of solar cells. What do you think differentiates monocrystalline from polycrystalline solar cells? Well, you might be surprised to know that the clue is in their names. Monocrystalline solar cells are derived from a single pure crystal of silicon. Picture a flawless, unbroken expanse of crystal, and you've got a pretty good idea of what we're talking about. This uniformity allows for an easy flow of electrons, a process that is crucial for the generation of electricity. This is the reason why monocrystalline solar cells are generally more efficient than their polycrystalline counterparts. Now let's turn our attention to polycrystalline solar cells. These are made by melting together many fragments of silicon crystals. Imagine a mosaic of different shards, all pieced together. This diversity of crystal orientations makes the flow of electricity slightly more challenging, resulting in lower efficiency compared to monocrystalline cells. But here's the twist. While monocrystalline cells are champions in efficiency, they're also typically more expensive. The process to create a single, pure silicon crystal is complex and requires specialized techniques. On the other hand, the production of polycrystalline cells is simpler and therefore less costly. This makes polycrystalline solar cells a more affordable option, particularly for large-scale installations. So you might be wondering which one is better. Well, it's not quite as simple as that. Both monocrystalline and polycrystalline solar cells have their unique advantages and disadvantages. If you're looking for maximum efficiency and space isn't an issue, monocrystalline cells might be your best bet. But if budget is a key consideration, or if you have plenty of space for installation, polycrystalline cells could be the more practical choice. It's also important to remember that while efficiency is a critical factor to consider, it's not the only one. Other considerations such as durability, longevity, and aesthetic appeal also play a role in making the right choice. For instance, monocrystalline cells typically have a sleek black appearance, while polycrystalline cells are usually blue and have a speckled look. These visual differences could be significant depending on where you plan to install the solar panels. In conclusion, the choice between monocrystalline and polycrystalline solar cells largely depends on your specific needs, circumstances, and preferences. Both have their merits and can be a great way to harness the power of the sun to generate electricity. So, while monocrystalline cells offer higher efficiency, polycrystalline cells bring affordability to the table. Moving on to a lighter and more flexible option, let's talk about thin-film solar cells. These solar cells are like the featherweights of the solar world. They are significantly slimmer and lighter than their silicon-based counterparts, and they often flex without breaking, which adds a new dimension of versatility to their utility. There are four common materials that are used to make thin-film photovoltaic cells, namely cadmium telluride, or CDTE for short, amorphous silicon, or AC, copper indium gallium selenide, known as SiGes, and gallium arsenide, abbreviated as GaAs. Each of these materials has its own unique properties that contribute to the overall performance of the thin-film solar cells. But despite their flexibility and durability, thin-film solar cells are less popular for residential and commercial installations. Why, you might ask? Well, it all boils down to efficiency. Thin-film panels lag behind silicon panels in this regard. For most homes and businesses, this means that they simply won't be able to produce enough electricity from thin-film options to meet their energy needs. But it's not all doom and gloom for thin-film solar cells. Some companies like First Solar have built their entire business model around producing panels with thin-film solar cells, specifically CDTE cells. Their target market? Large-scale utility power stations. These stations are always on the hunt for innovative ways to replace fossil fuel energy sources, and thin-film solar cells offer a viable alternative. So while thin-film solar cells might not be the go-to option for your home or small business, they have carved out a niche for themselves in the realm of large-scale power production. Their flexibility, durability, and lighter weight make them a perfect fit for projects where these characteristics are of paramount importance. Though not as efficient as silicon-based cells, thin-film solar cells have found their niche in large-scale utility power stations. Ever heard of solar cells that are not only flexible and durable, but also potentially transparent? Enter organic solar cells. These are a unique type of solar cell that hold a world of potential. What sets them apart is their composition. Unlike traditional and thin-film solar panels that are made from silicon or similar semiconductors, organic solar cells are made from carbon-based materials. This is why they are often referred to as plastic solar cells or polymer solar cells. These carbon-based materials give organic solar cells some impressive properties. For starters, they are flexible. This means they can be molded and shaped much more easily than their rigid silicon counterparts. This opens up a world of possibilities for where we can install solar cells, from curved surfaces to even clothing. In addition, organic solar cells are also durable. They can withstand the wear and tear of everyday use, making them ideal for applications where traditional silicon cells might not be suitable. But perhaps one of the most exciting aspects of organic solar cells is their potential for transparency. Imagine a world where every window could also generate electricity, turning every home, office, and skyscraper into a mini power station. This isn't just a pipe dream. Research is currently underway to develop transparent organic solar cells that could make this a reality. However, it's important to note that organic solar cells are not yet commercially viable. While they hold a lot of promise, there are still challenges to overcome. One of the main hurdles is efficiency. Currently, organic solar cells are less efficient than traditional silicon-based cells, but researchers are hard at work finding ways to improve this. Another challenge is longevity. Organic solar cells tend to degrade faster than silicon-based cells, but again, research is being done to find ways to extend their lifespan. Organic solar cells, with their unique properties, could revolutionize the way we incorporate solar energy into our daily lives. Last but not least, let's explore the potential of perovskite solar cells. Now, you might be wondering, what is a perovskite? Well, in the simplest terms, a perovskite is any material that shares the same crystal structure as the compound calcium titanium oxide, which is a type of semiconductor, much like silicon. But when we talk about perovskite solar cells, we're not using natural calcium titanium oxide. Instead, these solar cells use an artificial form of this compound. The result? A new type of thin-film solar panel that holds a lot of promise for the future of solar energy. Now, here's where things get really interesting. Perovskite solar cells have two major advantages that make them stand out from the crowd. The first is their low production cost. Unlike traditional silicon-based solar cells, which require high temperatures and complex processes to manufacture, perovskite solar cells can be made at much lower temperatures. This makes them cheaper and more environmentally friendly to produce. The second big advantage is their potential efficiency. While they're not quite there yet, research suggests that perovskite solar cells could one day reach efficiencies over 20%, which is on par with or even better than some of the best silicon-based solar cells on the market today. But it's not all sunshine and rainbows. There are still some challenges to overcome, such as improving their stability and longevity. But despite these hurdles, the potential of perovskite solar cells is undeniable. Their unique combination of low cost and high potential efficiency makes them an attractive option for the future of solar energy. As the solar industry continues to grow and evolve, perovskite solar cells represent an exciting and promising frontier. With ongoing research and development, they could very well become a major player in the solar energy landscape. Perovskite solar cells, with their promising features, could be one of the key players in the future of solar energy. So we've covered a lot of ground today. Let's quickly recap. We started with the two most common types of solar cells, monocrystalline and polycrystalline. Both are made from silicon wafers. Monocrystalline cells are crafted from a single crystal of silicon, resulting in higher efficiency, but also a higher price point. Polycrystalline cells, on the other hand, are made by fusing numerous silicon shards together. While slightly less efficient, these cells are generally more affordable due to their simpler manufacturing process. Next, we dove into thin-film solar cells, a lightweight and flexible alternative to traditional silicon cells. These cells are made from a variety of materials, including cadmium telluride, amorphous silicon, copper indium gallium selenide, and gallium arsenide. While less popular for residential and commercial use due to lower efficiency, thin-film cells have found a niche in large-scale utility power stations. We then explored the fascinating world of organic solar cells. These carbon-based cells are flexible, durable, and can even be transparent, lending themselves to innovative applications like solar windows. However, they're not quite commercially viable yet. Finally, we discussed perovskite solar cells, a type of thin-film solar panel made from an artificial calcium titanium oxide-based material. Although not widely available at present, their low production costs and high potential efficiency make perovskite cells an exciting area of ongoing research. It's clear that the solar cell landscape is far from monolithic. Each type of cell brings unique characteristics and potential applications to the table, contributing to the rich tapestry of our renewable energy future. As technology continues to advance, we can expect further innovation and diversification in this field, offering even more ways to harness the power of the sun. The world of solar cells is diverse and ever-evolving, each type bringing its unique contribution to our renewable energy future.